Most people think of AI as a tool you open and use, a chatbot, an image generator, a recommendation engine. But the deeper shift begins when AI stops looking like a tool at all and starts becoming infrastructure. Tools are visible. You choose when to use them. You interact with them directly. Infrastructure is different. It operates in the background. You depend on it without thinking about it. It shapes what is possible long before any individual decision is made. As AI systems mature, more of them are moving from the first category into the second. Early AI adoption often focuses on standalone applications. A team introduces an AI assistant. A company deploys an automated support bot. A developer uses a code generator. The interaction is clear and contained. But over time, these systems become embedded into workflows. They connect to databases, planning tools, logistics systems, and decision pipelines. What began as a visible feature becomes part of the operating layer of the organization. This shift matters because infrastructure influences behavior indirectly. When AI systems manage inventory forecasting, credit scoring, content ranking, or supply chain routing, they don't just support decisions, they structure them. Teams plan around automated forecasts. Financial institutions rely on model outputs for risk assessments. Platforms organize information through ranking systems that shape visibility and incentives. The AI is no longer something you consult, it becomes something you assume. You can already see this in logistics and retail. Demand forecasting models quietly determine how much stock is produced and where it is distributed. Route optimization systems structure how goods move across regions. No single user interacts with these systems directly, yet they shape availability, timing, and cost across entire industries. The infrastructure becomes invisible precisely because it works. A similar transition is happening in hiring and recruitment. AI systems increasingly filter resumes, rank applicants, and pre-screen candidates before any human interaction occurs. Applicants rarely see these systems. Recruiters may not fully understand how ranking thresholds are set, but the system structures the pool of opportunity long before interviews begin. When AI becomes infrastructure, it influences outcomes upstream. One reason this shift occurs is scale. Standalone tools serve individuals. Infrastructure coordinates systems. As organizations integrate AI more deeply, efficiency gains often depend on connecting multiple processes. That integration reduces friction, but increases dependency. Once a forecasting system is embedded across departments, removing it becomes difficult. The organization adapts around it. At that point, AI is no longer optional. A common counterargument is that AI remains under human control. After all, people design, deploy, and oversee these systems. That is true. But infrastructure changes the nature of oversight. Instead of evaluating individual outputs, humans monitor system performance through dashboards, metrics, and exceptions. The focus shifts from decisions to system behavior. That distance can make influence less visible, even when control technically remains. Another argument is that infrastructure-level AI increases resilience. Automated routing can respond faster to disruptions. Predictive maintenance can reduce downtime. Fraud detection systems can flag anomalies in real time. These benefits are real. Infrastructure can improve stability and efficiency at scale. The concern is not capability, it is dependency. When systems become foundational, failures have broader impact. A flawed model embedded across multiple processes can propagate errors quickly. Visibility decreases as reliance increases. There is also a governance dimension. Tools are easy to regulate at the point of use. Infrastructure is harder to evaluate because its effects are distributed. If a recommendation engine shapes public attention or a pricing model influences market behavior, the consequences are systemic rather than individual. Regulators and organizations alike often focus on visible applications while overlooking background systems that quietly shape incentives. Infrastructure rarely announces itself. This transition also affects perception. When AI is a tool, people debate whether to adopt it. When it becomes infrastructure, debate shifts to how it should be managed. The conversation moves from "should we use this?" to "how do we maintain and oversee this?" That change signals maturity, but also deeper entanglement. Importantly, not all AI systems will become infrastructure. Some remain tools, chosen and discarded as needed. Others integrate deeply into planning, logistics, finance, and communication networks. The distinction depends less on model capability and more on institutional adoption. Infrastructure emerges when systems are embedded across multiple layers of operation. Understanding this shift clarifies why AI's impact can feel gradual at first and structural later. Visible tools create attention. Invisible systems create dependency. Once embedded, AI shapes how organizations allocate resources, define success, and manage risk. Its influence becomes less dramatic and more constant. This doesn't imply inevitability or loss of agency. Infrastructure can be designed thoughtfully. Oversight mechanisms can evolve. Redundancy and transparency can be built into systems. But these choices require awareness. If AI is treated only as a collection of tools, its structural role may go unnoticed until it is deeply entrenched. As automation continues to spread, the most important changes may not come from the applications people talk about. They may come from the systems people stop noticing. When AI becomes infrastructure instead of a tool, it stops asking for attention. And that is precisely when its influence becomes most significant.